What's up, guys? Welcome back to the channel. Today on this video, as you can see here, we're gonna be solving the previous question paper that you see here. This previous question paper is on National Certificate Mathematics Info, and it was written on the 20th November 2024. It took about 3 hours to be written. Now, on this particular video, we want to focus on question 3. Now, before we start with that, I'd just like to say thank you very much, guys, for watching, subscribing, and also not forgetting those who comment and share the videos. If you haven't subscribed to the channel, subscribe to the channel because I've made lots and lots of videos based on question papers and previous question papers. Just in case you also haven't watched question 1 and question 2 of this question paper, I've already made videos on those. You can go to the description where I'll leave a link of the playlist that contains those questions and watch it. And also the very same playlist is going to pop up on the top right of this video. All right, guys, before we start though, I just like to let you know that on this video, I'll leave the timestamps where you will choose a specific video to watch if you're not willing to watch the whole video in a sequence order. So let's look at question 3 and let's see how we're gonna solve these problems. Right, as you can see, here's our question 3 here. Question 3 consists of 4 questions, and all these questions are trigonometry. So we're going to start with 3.1 and try to solve this question here. So what I'm going to do here, I'm going to copy this 3.1, paste it where there is space, and solve it. All right, guys, here's our question 3.1. Now, this question here, they want us to solve for the value of x if we are given the following expression here. So we have 1 over cos sec, open bracket, x minus 20 degrees, close bracket. All this is equaling to 1 over sec, open bracket, 20 degrees plus x, close bracket. And then they also give us the domain here. So the domain state that the x should be greater than 0, but less than 90. So whatever x that we're going to find here, or whatever the value of x that we're going to find here, it should be an acute angle, meaning it should be within the first quadrant. Now, let's start solving this problem here. Now, let's look at our left-hand side. Now, we have 1 over cos sec, open bracket, x minus 20 degrees, close bracket. Now, if you can look at this trigonometric function, this is actually the inverse of sine. So we can rewrite the left-hand side as sine x minus 20 degrees, right? Because this is the inverse. And we look at the right-hand side. Now, on the right-hand side, we also have 1 over sec, open bracket, 20 degrees plus x, close bracket. Now, this as well, it's also an inverse. This is an inverse of cos 20 degrees plus x. Now, when it's like this, guys, we use the inverses. Just in case you don't know much about inverses or you want to learn more about inverses, there is a video that I'm going to leave on the description, and also the very same video is going to pop up on the top right of this video. That video explains more about inverses. Right, so let's look at this here. Now we have the left hand side, which is sine, and the right hand side, which is cos. This method, guys, it's solving for x by using co-ratios, right? So if you can look on the left hand side, we have sine, which is a co-ratio of cos. Now you have to decide which of these two you have to change so that it can look like the other. Now, I would prefer to change the right hand side. So I will write sine x minus 20 degrees. All this is equaling to. So when you change cos, or when you find the co-ratio of cos, open bracket, 20 degrees plus x, it's going to be sine. Right. Now it's going to be 90 minus, open bracket, 20 degrees plus x. Right. Let me explain this very quickly. As you can see, the cos, open bracket, 20 degrees plus x is actually positive. For the fact that this cos is positive, it means that this is happening on the first quadrant because everything on the first quadrant is positive. Now the co-ratio of this one here, it's sine minus 90 degrees and the whole angle that you see here. Now, when it's like this is the co-ratio of cos on top there. So from here, now that you have sine on the left hand side and you have sine on the right hand side, they start to fall out. So as they fall out, you'll be left with x minus 20 degrees. And then on the other side, which is the right hand side, you're going to be left with 90 minus open bracket 20 degrees plus x. Then from here on the left hand side, you just rewrite it. There's nothing you can do at the moment. And on the right hand side, you're going to have to multiply by negative to remove the bracket. So we're going to have 20 degrees minus x. Now you start to do the like terms. Now on the left hand side, you can also leave it like that. It's still fine. But on the right hand side, we have 90 degrees minus 20. This is going to give us 70 degrees minus x. If we transpose this 20 on the left hand side to the right hand side, it's going to be positive. And also if we transpose this negative x to the left hand side, it's going to be positive. So we're going to have x, transpose this x to the other side, plus x because it was negative. And then this is going to be equal to, we have 70. And we transpose this 20 to the right hand side, and then we're going to have plus 20 degrees. Now we're going to have 2x, and then this is going to be 90. Now divide by 2, throw out our x is going to be 45 degrees. Right, so this is how you actually do this question. This is how you solve for x. As you can see, our x is within our domain. It's greater than 0 degrees and also less than 90 degrees. All right, guys, I hope you managed to understand this question here. Just in case you didn't understand, I will leave another video where I actually explain further or clarify how to actually solve for x with co-ratios. And also, I'm going to try to leave the co-ratio videos as well on the description. Go to the description and also check out the icon on the top right of this video to watch those videos. Okay, guys, now that we are done with 3.1, I hope you managed to understand. If this helped you to understand better, do not forget to like, share the video. If you haven't subscribed to the channel, subscribe to the channel. All right, guys, now that we're done with 3.1, how about we check 3.2? Right, guys, now let's look at 3.2. Now here's our 3.2 here. I will copy this question here and try to paste it where it's spaced so that you can able to solve it. All right, guys, let's look at our 3.2. Now 3.2, they want us to simplify as far as possible. Now we are given the following expression. We have cos x divided by 1 minus sine x minus cos x divided by 1 plus sine x. So what we're going to do here, guys, we have to simplify this. So let's solve this problem here. Now, first of all, we need to find our LCD. So we're going to take the denominators of both the terms. Right, just stretch it a bit here. So the denominator of the first term is going to be 1 minus sine x multiplied by the denominator of the second term, which is going to be 1 plus sine x. Then the next step here is to divide each denominator with our LCD, and then we multiply the answer with our numerator. We're gonna divide this 1 minus sine x, and we're gonna be left with 1 plus sine x multiplied by cos x, right? Minus. Then we go to the second term. We divide the LCD with our denominator of the second term, which is gonna be 1 plus sine x. So we're gonna have 1 plus sine x giving you 1 multiplied by 1 minus sine x multiplied by cos x. So this is going to give us cos x multiplied by 1 minus sine x. There we go. Right. All right. The next step is to simplify further. Now let's look at our numerator, the first term on the numerator. We have to remove the bracket by multiplying by the cos x outside the bracket. So we will say 1 multiplied by cos x, we're going to have cos x. And then we say plus sine x multiplied by cos x, we're going to have sine x cos x. Then we're done with the first term on the numerator. Minus. Then we multiply by Negative cos without 1, this is going to give us negative cos x. I mean, negative cos multiplied by negative sine x is going to give us positive sine x cos x. There we go. Let's not forget they are multiplying. Divide by. Right. Now, on the denominator, we need to remove the bracket. So we do the following. 1 multiplied by 1, this is going to give us 1. 1 multiplied by positive sine x is going to give us positive sine x. And then we say negative sine x multiplied by 1 is going to give us negative sine x. And then we say negative sine x multiplied by positive sine x, this is going to give us negative sine x squared. There we go. Then from here, we do the like terms. So let me highlight the like terms. On the numerator, we have cos and negative cos. So they're going to cancel each other. And then what we left with, we have sine x cos x and another sine x cos x. So these, they're going to give us 2 sine x cos x. There we go. And then we divide them. On the denominator, we also have the like terms. Now we have sine x and negative sine x. They're going to cancel each other. So on the denominator, we're going to be left with 1 minus sine squared x. All right, when I look at this step here, I can see that, I'm going to write it here. I can see that we have 2 sine x and then cos x. Right, divide by 1 minus sine x squared. This here, guys, is the same as cos squared x. Remember, this here is derived from cos squared x plus sine squared x is equaling to 1. When you make cos subject of the formula, here, cos squared x, you'll be left with 1 minus sine squared x, which is the same as this. So instead of writing this, we can substitute with cos squared x. Now that we have the following, we can start dividing. We know that we have 2 sine x. We know that since this cos squared, it is multiplying itself twice. One of the cos is going to divide with the cos on the numerator. And then you're going to only left with only cos x. And the answer here is going to be 2 tan x, because sine over cos gives you tan. Right, I hope you guys managed to understand this one. It was a bit complex, but not really that much. All you need to know is to simplify this further and try to use your trigonometric knowledge and identities that you know of. But guys, this was not that difficult. If it so happened that you didn't understand this, you can leave a comment in the comment section. I'll try to explain to you to my level best. But if it happens that this video helped you to understand how to simplify this type of questions, you can leave a like and also share the video. If it so happen that you haven't subscribed to the channel, subscribe to the channel. Guys, we are done with 3.2. How about we do 3.3? All right, guys, let's look at 3.3. As you can see, 3.3, this is the question for 3.3. I'm going to copy this, paste it where there is space, and try to solve it. All right, guys, here's our 3.3. As you can see, they want us to prove that sine 2x minus sine x divided by cos 2x plus cos is equaling to sine x over cos x plus 1. Now, when you do the proving, it's best to choose the most complicated side. As you can see, between the left-hand side and the right-hand side, the most complicated side is the left-hand side. So let's pick the left-hand side, prove it, and let's see if it's going to be the same as the right-hand side. Now, in order for you to solve this, you need to know things like double angle identities, and all types of trigonometry identities. So let's first look at our numerator then. Now, when I look at our numerator, I can see that this sine 2x is a double angle identity. I can rewrite it like this: 2 sine x multiplied by cos x, right, minus sine x. There we go. And then we divide underneath there, right? And then when I look at our denominator, the first term on our denominator, we have cos 2x. Also, this is a double angle identity. Now you can write it this way: 2 cos squared x minus 1 plus cos x. These here, guys, are actually double angle identities. Just in case you don't know much about double angle identities, you can go to the description where I've made a video about double angle identities. In fact, I derived them so that you can know how to derive them as well. You can go to that description, watch that video, and also the very same video will pop up on the top right of this video here. Right, so let's continue. Now, when we continue, you can see that on the numerator we have a common factor. So we take out our common factor, which is sine x, and then inside the bracket we're going to be left with 2 cos x minus 1. And then on the denominator we need to rearrange this. We can say 2 cos squared x plus cos x minus 1. All right, when you look at our denominator, this is actually quadratic. We have 2 cos squared x plus cos x minus 1. We can actually factorize this. Now let's continue. On our numerator, we're still going to write it as it is. Open bracket, 2 cos x minus 1. And then let's factorize our denominator. Now we can say we have 2 brackets like that. Just do this. And then we can say 2 cos x and cos x. Remember, when you factorize, guys, you must be able to go back. If you say 2 cos x multiplied by cos, it's going to take you to 2 cos squared x. Right. Now, let's look at our last term here of this quadratic. We have negative 1. What are the factors of negative 1? It's actually 1 and negative 1. So you need to be careful, where exactly do you actually place our positive 1. So first of all, you're going to put 1 there, because if you say 1 multiplied by 1, you're going to have this one. But then where exactly are you going to place the negative and the positive? Now you look at the term in the middle. We have cos x, which is positive. So the one that is going to multiply with 2 cos x must be positive, and then the one that is multiplying with cos x must be negative. So basically, this is how you do the factorization. All right, when you look at this step here, we have 2 cos x minus 1 and another 2 cos x minus 1 on the numerator. So these two, they will divide each other. So when you continue here, we're going to be left with sine x divided by cos x plus 1. Now, if we can look at this here, it's the same as that. So we can say, therefore, the right hand side is equaling to the left hand side. This was not difficult, guys. It just needed you to know the double angle identities and also know how to simplify the trigonometric functions that we have here. All right, guys, if this video helped you to understand better, do not forget to like, share, comment, and also not forgetting to subscribe to the channel if you haven't subscribed to the channel. If it so happen again that you didn't understand, you can leave a comment on the comment section. All right, guys, we are done with 3.3. How about we go and do 3.4? All right, guys, now let's look at 3.4. Now, 3.4, they want us to simplify this question here. Before we continue, I just want to clarify something here. Some people got confused. How exactly are we going to simplify this? So this question here is basically similar to 3.3, where you can prove that this left hand side is the same as the right hand side. So let me just copy this question, paste it, and let's solve it. All right, they want us to simplify this question. So this question, it's a bit confusing because people don't know where to begin. Is either we are proving or we are just simplifying. I would say this question here, they wanted you to prove that the left hand side is the same as the right hand side. Because if you punch this, this should give you 2 minus root 3. Meaning now you must able to prove that this side here is equaling to that side. Now I will show you how to do this, guys, very quickly. Now I'm gonna take the right hand side and let's solve this. But before I start, I need you to understand that in order for you to solve the right hand side, you need to understand special angles. So we have these special angles here on this triangle. Just be quick about it. All right, so we have these special angles here. As you can see, we have sine 30 and we also have cos 30. So these ones here, they will need us to use the special angle. Even though they never specified whether to use a calculator or not, but I would say when you come across this type of equation, rather use special angles. Just in case you don't know much about special angles, I've made a video on special angles. Go to the description. There will be a link based on those special angles, and also the very same video will pop up on the top right of this video. Right, so let's start. First of all, you need to change sine 30. So we know that sine is the same as opposite over hypotenuse. Now, when you look at this triangle here, what is our opposite of 30? It's going to be 1, right? The hypotenuse is going to be 2, right? So this is divided. So I rather use this type of divide by 1 plus cos 30. So I can put this in the bracket, 1 plus, but what is cos 30? Remember, cos is adjacent over hypotenuse. So our adjacent here for 30 is root 3, and our hypotenuse is 2. Right, so when it's like this, it's easy for us to continue and solve this problem here. Right, so let's continue. But before we continue, just in case you don't know much about the trigonometric ratios, I will leave the video on the description. Go and watch those videos on trigonometric ratios so that they can help you to understand better. But let's continue here. Now, on this side here, we're going to leave that half as it is, and then we're also going to divide, but then inside the bracket, we're going to start solving. So we're going to put our LCD here, which is 2. This is going to give us 2, and then we say plus. And then we say 2 divided by 2 is going to give us 1, multiplied by root 3. This is going to give us root 3. Right. Then when you continue here, this half is going to remain like this for now. And then we do the multiplication. Remember, guys, when you change division into multiplication, this bracket here, these numbers here, the numerator become a denominator and the denominator become a numerator. Meaning that 2 becomes a numerator, and then 2 plus root 3 become a denominator. So when it's like this, it means that we have 2 divided by 2, which is going to give us 1. Let me continue here. So we will be left with 1 over 2 plus root 3. This is the answer, but I wouldn't say leave it here. You should start rationalizing. So let's rationalize. So when you rationalize, you multiply by 2 minus root 3 divided by 2 minus root 3. As you can see, this gives you 1, but at the same time, you are rationalizing. So on the numerator, you say 1 multiplied by 2, 1 multiplied by negative root 3. So you're going to have that on the numerator. But on the denominator, we say 2 multiplied by 2. This is going to give us 4. 2 multiplied by negative root 3. This is going to give us negative 2 root 3. And we say root 3 multiplied by 2. This is going to give us 2 root 3. And then we multiply root 3 multiplied by negative root 3. This is going to give us negative 3. Right, so let's continue. When you continue here, on top there, on the numerator, we're going to have 2 minus root 3. But on the denominator, we have the like terms. So let me highlight the like term very quickly. So we have negative 2 root 3 and positive 2 root 3. So these ones, they will cancel each other. But at the same time, we have 4 minus 3. So 4 minus 3, we're going to be left with 1. So let me just do it here. 1. If I continue here, we know that we left with 2 minus root 3 divided by 1. Even if you don't write that one, but this is the same as tan 15. If you can punch tan 15 degrees, you will get 2 minus root 3. Guys, I know this was a bit ambiguous, but I hope you can manage to get the answer here, or you manage to understand how exactly they wanted the answer. If it so happen that this video helped you to understand this type of a question better, you can leave a like, comment, and also share the video. If you haven't subscribed to the channel, subscribe to the channel. If you didn't understand, do not forget to leave a comment and ask the question, and I'll try to answer you to my level best. Guys, we are done with 3.4. Now that we are done with 3.4, we're also done with question 3. The next video will be on question 4. So make sure that you subscribe, you hit the bell notification so that you can able to be notified whenever I upload question 4. Thank you very much, guys, for watching. Till next time, cheers.